Picture this. Somewhere in Africa, maybe 500,000 years ago, maybe a million. The exact date doesn't matter. What matters is the moment. A human ancestor sits by a fire as darkness settles over the landscape. Predators call in the distance. The fire crackles. And then, without thinking, without planning, this person makes a sound. Not a word, not a warning cry. Something else entirely. A melody. A hum that rises and falls for no reason except that it feels right. The first song humanity ever sang into the void. Nobody was there to record it. No notation survived. But it happened. It must have. Because today, tens of thousands of generations later, we're still doing it. Still making organized sound for reasons we can't fully explain. Here's the mystery that keeps scientists, anthropologists, and philosophers up at night. Why does music exist at all? Think about it. Really think about it. Music doesn't feed us. It doesn't build shelter. It doesn't fight off predators or cure disease. You can live a perfectly functional life without ever hearing a melody. And yet there has never been a human culture discovered anywhere on Earth that doesn't have music. Not one. From the Arctic to the Amazon, from isolated islands to modern cities, every group of humans ever studied makes music. If you're using this video to fall asleep, that's exactly why I make these. So subscribe maybe, and leave a comment telling me where you are and what time it is. I check them all and it's wild. Tokyo at sunrise, London at midnight, São Paulo during lunch break. All listening to the same mystery at the same time. But back to that mystery. Music is universal, yet it serves no obvious survival function. It's one of the most energy-intensive things humans do. Creating music requires complex brain activity, fine motor control, memory, emotional processing, and social coordination. From an evolutionary perspective, it should be a waste of resources. Natural selection should have eliminated it. But instead, we've been making music for so long that we've literally evolved specialized brain circuits just to process it. The really mind-bending part? Music is older than almost everything we think of as human civilization. It predates writing by tens of thousands of years. The oldest known written text is maybe 5,000 years old. But musical instruments have been found that are over 40,000 years old. And those are just the ones that survived. The actual bones and ivory that didn't rot away. Imagine how much older the tradition must be if people were crafting sophisticated flutes 40 millennia ago. Music predates agriculture. Before humans planted the first crops, we were making melodies. It predates permanent settlements. Before we built the first villages, we were drumming rhythms into the night. And here's where it gets really strange. Music might actually predate language itself. At least language as we know it. Some scientists believe our ancestors were making organized, meaningful sounds, proto-music, before they could speak in complex sentences. That the capacity for melody came before the capacity for grammar. Think about what that means. Before we could say, "The lion is hunting near the water," we might have been able to sing our feelings about danger and water and death. Before we had words for love or fear or joy, we might have had melodies that expressed those emotions. Sound before symbol, music before meaning. But why? That's the question we're going to explore. Why would natural selection favor beings who waste time and energy making sounds that don't help them survive? What possible advantage could there be in organizing vibrations in the air into patterns that make us feel emotions we can't even name? The answer, as we'll discover, takes us into ancient caves where Neanderthals carved flutes from bare bones, into the genetics of how our brains process rhythm and melody, into the question of whether our ancestors who survived that brutal population bottleneck 900,000 years ago sang to each other in the darkness, into the mysterious connection between music and language, two systems that seem so different but share so much neural architecture, and ultimately into the deepest questions about what makes us human. Because here's the thing, every human culture has creation myths, stories about how the world began, and in a remarkable number of those myths, the world doesn't start with a word or an action, it starts with a sound, a vibration, a song sung into the void that brings reality itself into being. Maybe those myths are trying to tell us something true. The mystery of why music exists is really the mystery of why we exist, and it's older than language itself. Let's talk about the oldest human-made object designed purely for making sound. Not a tool for cutting, not a weapon for hunting, not a vessel for carrying water, an instrument. Something created for the sole purpose of producing organized, intentional, beautiful noise. It's a flute, and it's sitting in a museum in Tübingen, Germany right now, looking remarkably unimpressive for something that fundamentally challenges our understanding of what it means to be human. This flute is 40,000 years old. Think about that number for a moment. 40,000 years, not 400. Not 4,000. 40,000 years ago, your ancestors were living through the last ice age. Glaciers covered most of Europe. Woolly mammoths wandered through forests that would later become Paris and London. Neanderthals were still alive, still hunting, still making their own tools in territories they'd occupied for hundreds of thousands of years. And somewhere in what is now southern Germany, a human being sat down with a vulture bone and decided to make music. The flute was discovered in 2008 in a cave called Hohle Fels, part of a network of limestone caves in the Swabian Alps that have become one of the most important archaeological sites in human history. The cave had been occupied on and off for thousands of years, serving as shelter for successive generations of Ice Age humans. The archaeological layers are like a timeline you can dig through, each level representing a different moment in human history, a different group of people trying to survive in a world that was brutally, unforgivingly cold. The flute was found in the deepest layer, the oldest occupation. It was made from the radius bone of a griffon vulture, one of the largest flying birds in Europe. Vultures have hollow bones, lightweight and strong, perfect for flight. But this human saw something else. They saw a potential instrument. They took that bone and transformed it into something that had never existed in nature, something that could create sounds that no animal could make. The craftsmanship is extraordinary. This wasn't some crude experiment, some accidental discovery that if you blow across a hollow bone it makes a noise. This was deliberate, sophisticated manufacturing. The maker had carved 5 finger holes along the length of the bone, positioned with careful precision. They had beveled the edges of the mouthpiece to make it easier to produce sound. They had even carved small V-shaped notches near the ends of the holes, probably to prevent the bone from cracking during use. Most incredibly, when researchers made replicas and tested them, they discovered the finger holes were positioned to produce notes that approximate a diatonic scale. The same basic scale structure that underlies most modern Western music. This wasn't random. The maker understood something about acoustics, about the relationship between hole position and pitch. They were creating an instrument capable of producing melodies, not just noise. But the Hohle Fels flute isn't alone. The same cave system has yielded multiple instruments, each one adding to our understanding of Ice Age musicality. Just a few kilometers away, in another cave called Geissenklösterle, archaeologists found fragments of flutes made from mammoth ivory. Think about that manufacturing challenge. Mammoth ivory is solid, not hollow. To make a flute, you have to split the tusk lengthwise, hollow out 2 channels, then glue the pieces back together with an airtight seal using Ice Age adhesives. This is advanced engineering. This requires planning, specialized tools, and knowledge that has to be learned and taught. These aren't the only Ice Age instruments we've found. Dozens of bone flutes have been recovered from sites across Europe, ranging from 40,000 to about 30,000 years old. Each one shows similar sophistication: carefully positioned finger holes, beveled edges, evidence of repair when they broke, showing they were valued objects, worth maintaining and using for extended periods. But here's where the story gets really interesting and really frustrating. Flutes survive because they're made of bone and ivory, materials that can last tens of thousands of years under the right conditions. But what about instruments made from materials that don't preserve? Wood rots, plant fibers decay, hide drums disintegrate. Anything made from perishable materials vanishes from the archaeological record within years or decades, leaving no trace. So when we say the oldest known instruments are 40,000 years old, we're not really saying music began 40,000 years ago. We're saying that's when humans started making instruments from materials that happened to preserve well enough for archaeologists to find them 40 millennia later. The actual origin of instrumental music could be far, far older, and that's before we even consider the most obvious instruments of all. Ones that leave absolutely no archaeological trace whatsoever. Your voice, your hands, your feet stamping on the ground. Every human culture ever documented engages in vocal music and rhythmic percussion. There are no exceptions. Isolated tribes contacted for the first time in the Amazon, the Arctic, the islands of the Pacific. They all have music. They all sing. They all create rhythm by clapping, stamping, striking objects together. These forms of music making are universal, suggesting they're ancient, far older than any physical instrument we've ever found. Some researchers think the first human music was percussive. Our ancestors figuring out that striking rocks together in patterns, or hitting hollow logs with sticks, or clapping their hands in rhythm, created something that felt meaningful, something that got people's attention and synchronized their movements. There's actually some archaeological evidence for this. At sites across Africa and Europe, archaeologists have found rocks that show patterns of impact marks consistent with being struck repeatedly, deliberately. Not tool-making impacts which leave different patterns. These are rhythmic strikes. Someone was using these rocks as percussion instruments, creating beats in the darkness of the Ice Age. Other researchers think vocal music came first. After all, you don't need to manufacture a voice. It's built in, ready to use from birth. Every human culture develops elaborate vocal traditions, songs passed down through generations, modified and refined. If language evolved, as most anthropologists believe, somewhere between 200,000 and 100,000 years ago, then the ability to control vocal pitch and rhythm evolved with it. Once you can speak, you can sing. The cognitive equipment is the same, but the bone flutes tell us something that goes beyond just the question of when humans started making music. They tell us about what music meant to the people who made them. Remember, these flutes were created 40,000 years ago, during one of the harshest periods in human history. Ice Age Europe was not a friendly place. Winters were brutal, lasting months. Food was scarce and difficult to obtain. Every calorie had to be fought for, every resource carefully managed. Survival required constant attention, constant work, and yet despite all that, despite living on the edge of starvation in a frozen landscape, someone took the time to make a flute. Not just a crude whistle, but a sophisticated instrument requiring hours of skilled labour. They carved it carefully. They tuned it. They played it. And others valued it enough that when it broke, they tried to repair it instead of just making a new one. This tells us music wasn't just entertainment to these people. It wasn't something they did when all the important work was finished. It was important work. Important enough to justify the enormous investment of time and skill required to create these instruments. important enough that people carried them, used them, maintained them, passed them down through generations. What were they playing? We'll never know. Music doesn't fossilize. The melodies are lost forever, disappeared into the cold air of Ice Age caves 40,000 years ago. But we can imagine. Archaeological evidence from these cave sites shows they were gathering places. Multiple hearths, evidence of group activities, remains of communal meals. People came together here, and when they did, someone probably pulled out a flute and started to play. Picture it, it's 40,000 years ago. The sun has set, and the temperature outside the cave entrance is dropping fast. Inside, a fire burns, casting flickering shadows on the limestone walls. A group of humans sits together, maybe 20 or 30 people. Extended family. A band that's been travelling together for months, following herds of reindeer across the tundra, trying to stay alive through another brutal winter. Someone begins to play the flute. The sound is haunting, breathy, not quite like any modern instrument. Others join in, clapping, stamping their feet, creating rhythm. Voices rise, singing words in a language that hasn't been spoken in 40,000 years. The music echoes off the cave walls, fills the space, transforms it from a cold stone shelter into something else, something sacred, something human. For a few minutes, or a few hours, the desperate struggle for survival fades. The fear of starvation, the memory of friends and family lost to the cold, the constant anxiety about whether tomorrow will bring food or danger, all of it recedes. There's just the music, just the sound, just this moment of connection between individuals who know they might not all survive the winter, but who are together now, creating something beautiful in the darkness. That's what the flutes tell us. Not just that humans made music 40,000 years ago, but that music was important enough to them that they invested precious resources in creating it. That when faced with a world of scarcity and danger, they chose to make beauty. That music was, somehow, essential to what it meant to be human. And here's the truly mind-bending part. Those Ice Age flute makers were anatomically identical to you. Same brain size, same cognitive capabilities, same emotional range. If you could somehow transport an infant from that cave into the present day, they would grow up perfectly normal, indistinguishable from anyone else. And if you could transport a modern infant back to the Ice Age, they would learn to make bone flutes and sing songs around fires in limestone caves. We are them. They are us. Separated by 40,000 years of history, but connected by the same fundamental need to create organized sound, to make music, to sing into the darkness and hear something beautiful echo back. But the question remains, why? Why would evolution create a species that needs music so badly? We'd invest scarce resources in making instruments during an ice age. What possible survival advantage could music provide that would justify its existence across every human culture in history? That's where the story gets even stranger. Now we need to ask a question that gets even stranger. Was music ours alone? Did it belong exclusively to Homo sapiens? Or were we inheriting something that had been developing long before our species even existed? The answer might surprise you, because the evidence suggests that when our ancestors finally evolved into anatomically modern humans around 300,000 years ago, they weren't discovering music for the first time, they were inheriting it, from beings who weren't quite human. Not yet. Let's start with the Neanderthals. Those robust, cold-adapted relatives who split off from our lineage around 800,000 years ago during the recovery from the bottleneck. For decades, popular culture portrayed them as grunting brutes, incapable of sophisticated thought or culture. But everything we have learned in the past 30 years has demolished that stereotype. Neanderthals buried their dead with apparent ritual. They cared for injured and elderly group members. They created art, wearing jewellery made from eagle talons and painting abstract symbols on cave walls. They were cognitively sophisticated beings with rich inner lives. So could they make music? The most tantalising evidence comes from a cave in Slovenia. In 1995, archaeologists working at Divjabeb Cave discovered something extraordinary embedded in the sediment. A short section of cave bear femur, roughly 43,000 years old, with 4 precisely spaced holes pierced through it. It looked, for all the world, like a flute. If authentic, this would be the oldest musical instrument ever found, predating the arrival of modern humans in Europe by thousands of years. It would mean Neanderthals were making music, actually crafting instruments, understanding acoustics, creating deliberate sound patterns for something beyond survival. But there's a problem, a big one. Cave bears have powerful jaws, they chew on bones, and carnivore teeth can, in theory, create holes that might look deliberately placed. The scientific community immediately split. Some researchers insisted the holes were too regular, too precisely aligned with where finger holes would need to be to produce a musical scale. Others argued that natural processes, combined with human pattern-seeking bias, were creating an illusion of intentionality where none existed. 25 years later, the debate hasn't been resolved. Statistical analyses of the hole placement have been conducted. Experimental archaeology has tried to recreate the damage carnivore teeth would make. Some studies support the flute hypothesis, others don't. The Divjabeb object remains tantalizingly ambiguous, neither definitively proven nor definitively debunked. But here's the thing. Even if this particular object isn't a flute, the question it raises remains valid. Could Neanderthals make music? And the answer, based on everything else we know about their anatomy and cognition, is probably yes. Consider their hyoid bone. This small horseshoe-shaped bone in the throat anchors the muscles used in speech and vocalization. Modern humans have distinctively shaped hyoids that allow for the precise vocal control necessary for language. For decades, researchers assumed earlier human species had differently shaped hyoids that would have limited their vocal capabilities. Then they found Neanderthal hyoid bones, and they were virtually identical to ours. This doesn't prove Neanderthals could speak exactly like us. Vocalization involves more than just one bone, but it strongly suggests they had the anatomical equipment for sophisticated sound production. They could modulate pitch, control breath, create sustained tones, all the physical prerequisites for singing. Their ear structures tell a similar story. Analysis of Neanderthal skulls shows middle ear bones and auditory canal dimensions very similar to those of modern humans. They could hear the same frequency ranges we can. They were sensitive to the kinds of pitch variations that matter for music and speech. Their brains, larger than ours on average, had well-developed temporal lobes where auditory processing happens. They had the hardware for music. The question is whether they had the software. The cognitive capacity to conceive of organized sound as meaningful, as worth creating deliberately. Archaeologist Stephen Mithen thinks they did. More than that, he thinks music might have actually preceded language in human evolution. In his book, he proposes something called the hypothesis. It stands for holistic, manipulative, multimodal, musical, and mimetic. His idea is that before early humans developed true language with discrete words and grammar, they communicated through something more like music. Long, melodic vocalizations that conveyed emotion and general meaning, but lacked the specific semantic content of language. Think of it like this. A mother soothing a crying infant doesn't use grammatically correct sentences. She uses melody, rhythm, changing pitch contours that calm without conveying specific information. That's emotional, social communication through organized sound. Mithen argues this kind of musical proto-language would have been the stepping stone to true language. Natural selection would favour individuals who could modulate their vocalizations more precisely, eventually leading to the discrete units of sound we call words. If he's right, then Neanderthals, who split from our lineage before modern language fully evolved, might have retained more of this musical proto-language while modern humans were developing increasingly sophisticated verbal language. They might have been more musical than us in some ways, more reliant on melody and rhythm for social bonding and communication. It's a beautiful idea, impossible to prove, but hauntingly plausible, and it raises an even bigger question. If Neanderthals had musical capacity, and modern humans have musical capacity, then maybe our common ancestor who lived 800,000 years ago, those survivors of the bottleneck, they had it too. Music wouldn't be something that evolved independently in both lineages. It would be part of our shared inheritance from deeper in the past. How much deeper? Consider Homo erectus. This species appeared nearly 2 million years ago. They were the first humans to spread out of Africa, colonizing much of Asia and Europe. They mastered fire, crafted sophisticated stone tools, and survived for longer than any other human species. 1.9 million years is an extraordinary run. For context, modern humans have only existed for about 300,000 years. Homo erectus was successful on a timescale we can barely comprehend. Did they sing around their fires? Did they drum on hollow logs? Did mothers hum to their babies? We have no direct evidence, but we know they had the anatomy for complex vocalization. Their hyoid bones, though not identical to ours, were more similar to modern human hyoids than to those of earlier hominins. They had sufficient breath control for sustained vocalization. Otherwise, they couldn't have maintained the complex group coordination necessary for activities like controlled burning and cooperative hunting. And they had time. 1.9 million years is enough for significant cultural evolution. If even a proto-musical capacity emerged early in Homo erectus evolution, there would have been hundreds of thousands of generations for it to develop and refine. By the time Homo erectus populations gave rise to later species like Heidelbergensis, the common ancestor of both Neanderthals and modern humans, musical behaviour could have been deeply embedded in the hominin lineage. We might push even deeper. Homo habilis, the earliest species in our genus, appeared around 2.4 million years ago. They're associated with the first stone tools. The cognitive leap necessary to conceive of a tool, to see a rock not as just a rock, but as a potential implement for cutting or smashing, that's abstract thinking. It's not so different from the cognitive leap necessary to conceive of organised sound as something meaningful, as music, rather than just noise. But here's where we reach the limits of what evidence can tell us. The further back we go, the more speculative everything becomes. We have bones, stones, and genes. We don't have recordings or written accounts. We can't know with certainty when rhythm first felt meaningful to a hominin brain, when a sustained tone first created an emotional response, when two individuals first synchronized their vocalizations and felt the strange pleasure of harmony. What we can say is this: music, in the sense of deliberate organization of sound for social and emotional purposes, appears to be very old. Older than our species, probably older than our genus. It may trace back millions of years into the hominin lineage, developing in parallel with language, tool use, and all the other cognitive abilities that make us human. This is humbling. We like to think of music as one of our great achievements, and in its most sophisticated forms, symphonies and operas and jazz improvisations, it is. But the instinct underlying all of it, the impulse to organize sound and find meaning in rhythm and melody, that didn't start with us. We inherited it from beings whose names we'll never know, who lived and loved and raised children and faced the darkness, not with words, but perhaps with song. Somewhere in the African savannah, maybe 2 million years ago, maybe more, A hominin mother held her infant and made sounds that weren't quite language, but weren't quite music either. Something in between. Something that calmed the child, strengthened their bond, helped them both survive another day. That behaviour got passed down through generations, refined by natural selection, elaborated by cultural evolution. It survived the bottleneck. It diverged into Neanderthal music and Denisovan music and the musical traditions that would eventually become ours. We are, all of us, inheritors of that first song, the one that predates our species, predates our language, maybe even predates our consciousness as we understand it. Music wasn't something we invented. It was something we became capable of recognizing, refining, and finally understanding. But the impulse was always there, coded in neural circuits that formed long before the first Homo sapiens drew breath. And if music is that old, if it's woven that deeply into what it means to be human, or even pre-human, then maybe it's serving a purpose even more fundamental than we've imagined. Maybe it's not just for pleasure or social bonding. Maybe it's something more essential, something that helped keep those ancient populations alive when extinction was always just one drought away. What could possibly be that important? Important enough to persist across 2 million years of evolution? Important enough that natural selection would preserve and refine it through bottlenecks and migrations and the rise and fall of entire species? That's the question we need to answer next. Because music doesn't just exist, it exists for a reason, and that reason might be stranger and more wonderful than anyone has guessed. Here's where things get really strange. We have evidence that music is ancient, that our ancestors were crafting flutes and drums when they were still living in caves and hunting mammoths. But why? Why would evolution favour something that seems, on the surface, completely useless? Charles Darwin himself was baffled. In The Descent of Man, published in 1871, he wrote openly about his confusion. Music, he observed, was universal among human cultures. Every society ever studied, from Arctic hunters to Amazonian tribes, had music. But unlike language, which clearly helped people communicate survival information, music seemed to serve no practical purpose. You can't eat it. You can't use it to fight off predators. You can't build shelter with it. Darwin was puzzled because natural selection is supposed to be ruthlessly efficient. Traits that don't contribute to survival and reproduction get eliminated. Every feature of your body, every instinct, every behavioral tendency exists because at some point in the past it helped your ancestors stay alive long enough to have children. So what was music doing there? Why would evolution waste energy and brain tissue on something that appeared to be purely decorative? His confusion was justified. Music is actually quite expensive from an evolutionary standpoint. The neural machinery required to process rhythm, recognize melodies, and experience emotional responses to sound takes up significant brain real estate. Brains are metabolically costly. Human brains consume about 20% of our total energy budget, despite making up only 2% of our body weight. Every cubic centimetre of brain tissue needs to justify its existence, needs to provide some advantage that outweighs its cost. And music demands a lot of that precious neural territory. We have specialised brain regions for processing pitch, for tracking rhythm, for recognising familiar melodies, for coordinating movement to beat. We have neural circuits that connect sound processing to emotion centres, allowing music to make us cry, to give us chills, to fill us with joy or melancholy. All of this is expensive. All of it requires justification. So Darwin proposed one answer: sexual selection. The same force that gave male peacocks their absurdly expensive tail feathers, that gave male deer their unwieldy antlers, might have given humans music. Not because it helped individuals survive, but because it helped them attract mates. Think about it. Musical ability requires good genes. You need excellent fine motor control to play instruments, sophisticated auditory processing to recognize pitch, cognitive flexibility to learn complex patterns, and enough surplus energy to spend time practicing instead of just scraping by. A talented musician is advertising all of this. They're saying, "Look at me. My genes are so good, I can afford to waste time and energy on something completely impractical." This is called a costly signal. In evolutionary terms, the most honest signals are the ones that are expensive to produce and difficult to fake. A sickly individual with poor genes can't afford to invest energy in music, but a healthy individual with good genes can. So by demonstrating musical ability, you're providing potential mates with reliable information about your genetic quality, and the evidence supports this, at least partially. Musical ability does correlate with other markers of genetic fitness. Professional musicians tend to have higher IQs, better motor coordination, and more symmetrical faces, which is itself a marker of developmental stability. In traditional societies, talented musicians often have more sexual partners and more offspring. Even today, surveys consistently show that musical ability makes people more attractive as potential partners. But sexual selection can't be the whole story, because music isn't just about individual performance, it's fundamentally social. Yes, there are musical virtuosos who dazzle audiences with solo performances, but for most of human history, music has been a group activity. People sing together, they dance together, they create rhythm together. This led anthropologists to propose a different theory, music as social glue. In this view, music evolved not to attract mates, but to create and maintain group cohesion, to bind individuals into functioning tribes capable of cooperation on a scale no other primate could manage. And this makes tremendous evolutionary sense. Remember those bottleneck survivors, scattered across Africa in tiny groups of 20 or 30 individuals. Their survival depended on cooperation. Not just casual cooperation, but sustained, sophisticated coordination across extended periods. They needed to hunt together, share resources, care for each other's children, maintain complex knowledge systems across generations. But cooperation is hard. It requires trust. It requires shared identity. It requires mechanisms that override our natural selfishness and make us care about group success, even when it conflicts with individual gain. Music, these theorists argue, provided exactly those mechanisms. When people make music together, something remarkable happens in their brains. Rhythmic synchronization, moving or singing in time with others, triggers release of endorphins and oxytocin, the same neurochemicals involved in mother-infant bonding and romantic attachment. These chemicals create feelings of trust, empathy, and social connection. They literally make you feel closer to the people you're making music with. More remarkably, music synchronizes brain activity between individuals. Studies using EEG to measure neural activity show that when people sing together or play instruments together, their brainwaves begin to align. Separate individuals become, in a very real neurological sense, a unified system. Decision-making becomes easier. Communication becomes more intuitive. The group starts functioning as a coordinated unit. For small bands of humans trying to survive in hostile environments, this would have been invaluable. Groups that could synchronize through music would have been better at coordinated hunting, better at organized defense, better at maintaining cooperation during times of stress. Over thousands of generations, groups with strong musical traditions would have outcompeted groups without them. Not because music helped individuals, but because it helped groups survive as cohesive units. The archaeological evidence supports this. Those 40,000-year-old flutes from German caves. They weren't found alone. They were found in sites showing evidence of complex social organization, of groups engaging in coordinated activities, of communities maintaining elaborate cultural practices across multiple generations. But there's another theory, one that predates both sexual selection and social bonding: the mother-infant hypothesis. Before music became a tool for attracting mates or binding tribes, it might have started as something much simpler: communication between mothers and babies. Human infants are uniquely helpless. Unlike other primate babies who can cling to their mothers and are mobile within weeks, human babies are dependent for years. This creates an intense selection pressure for any behavior that strengthens the mother-infant bond and facilitates communication before language develops. And infants are deeply responsive to musical sound. Long before they understand words, babies respond to lullabies, to rhythmic rocking, to the melodic contours of infant-directed speech, what we call baby talk. These aren't cultural inventions, they're human universals. Mothers in every culture, speaking every language, automatically shift into a more musical mode when addressing infants. Higher pitch, exaggerated melodic contours, rhythmic repetition, and it works. Infants calm faster to singing than to speech. They maintain attention longer when information is delivered musically. They form stronger attachments to caregivers who engage in musical interaction. From an evolutionary perspective, this makes perfect sense. Mothers who could soothe infants musically would have had babies who cried less, attracting fewer predators. Infants who responded to musical communication would have maintained stronger bonds with caregivers, increasing their chances of survival. According to this theory, music's later elaborations, the complex songs, the instruments, the group performances, were all built on this foundation. The neural circuits evolved to facilitate mother-infant communication were later co-opted for mate attraction and social bonding. The emotional power of music, its ability to move us without words, is a legacy of its origins in the pre-verbal relationship between caregiver and child. But not everyone is convinced that music required its own evolutionary justification. Steven Pinker, the cognitive scientist, famously argued that music is auditory cheesecake. By this he meant it's a pleasant byproduct of other adaptations, but not itself adaptive. Just as cheesecake hijacks taste preferences that evolved to make us seek out nutritious foods, music hijacks neural systems that evolved for other purposes. Language gave us sensitivity to complex sound patterns. Social cognition gave us the ability to track and predict the behavior of others. Motor control gave us the ability to coordinate precise movements. Music, in Pinker's view, is just what happens when you combine these systems in novel ways. It's pleasurable because it stimulates neural circuits that normally serve useful functions, but the pleasure itself doesn't serve any purpose. It's just a happy accident. This is the auditory cheesecake theory, and it has some appeal. It's parsimonious. It doesn't require inventing new evolutionary pressures or adaptive stories. But it also has problems. Mainly, it can't explain why music is universal, why every human culture invests enormous resources in musical activity, or why our brains have specialized regions seemingly dedicated to music processing. If music were just a byproduct, you'd expect it to be optional, something some cultures developed and others didn't. But it's not. It's as universal as language, as universal as cooking food or making tools. The truth is probably that no single theory explains everything. Music might have started as mother-infant communication, then been elaborated for social bonding, and then further refined through sexual selection. Or maybe it emerged for social bonding first, and was later adapted for courtship and caregiving. Evolution doesn't work in straight lines. It takes whatever materials are available and repurposes them, creating complex systems that serve multiple functions simultaneously. What we know for certain is that music does something profound to human brains. Modern neuroscience has confirmed this beyond doubt. When you listen to music, especially music you love, your brain releases dopamine, the same neurotransmitter involved in food, sex, and addictive drugs. This is why music can give you chills, why it can create intense pleasure from nothing but organized sound waves. Music also activates the prefrontal cortex, the region involved in planning and abstract thinking. It engages the motor system, even when you're sitting still. It triggers emotional processing centers in ways that few other stimuli can match. And when you make music with others, it creates that remarkable brain synchronization, turning separate individuals into a temporally unified neural network. This is power. Real, measurable, biological power, and evolution doesn't waste that kind of neural machinery on accidents. Whatever the original reasons, music became deeply embedded in what it means to be human. It shaped our brains, influenced our social structures, and possibly contributed to our success as a species. Those bottleneck survivors struggling to maintain cooperation across scattered groups during 117,000 years of near extinction. They might have survived partly because they could sing together, because rhythm and melody helped them feel connected even when separated by vast distances, because lullabies helped mothers soothe infants through desperate times, because courtship songs helped individuals find mates even when populations were dangerously small. We can't know for certain. The selection pressures are lost in deep time, but the legacy remains, written in the structure of our brains, expressed in every culture that has ever existed. Music is a mystery, yes, but it's a mystery that has been shaping human evolution for hundreds of thousands of years, maybe longer. And it's not done with us yet. Here's what happens in your brain when you hear music. Not background noise, not speech. Music. A flute plays a simple melody. Just 3 notes, rising and falling. In the 300 milliseconds it takes for that sound to travel from your ear to your consciousness, something extraordinary occurs. Something no other stimulus does quite the same way. The sound waves hit your eardrum, get converted to mechanical vibrations, then electrical signals. Standard sensory processing. Your auditory cortex, buried in the temporal lobe above your ears, decodes the frequency, the pitch, the timbre. It recognizes flute and melody. But that's just the beginning, because unlike almost any other sensory input, music doesn't stop at the sensory processing regions. It explodes across your entire brain like nothing else. Auditory cortex, yes, but also the motor cortex, planning movements even though you're sitting still. The cerebellum, tracking rhythm and timing with millisecond precision. The prefrontal cortex, making predictions about what note comes next. The limbic system, flooding you with emotion. The hippocampus, pulling up every memory associated with sounds like this. Neuroscientists using fMRI scanners have watched this happen in real time. When subjects listen to music, their brains light up like Christmas trees. Nearly every major region activates simultaneously, creating patterns of neural activity that don't occur with speech, environmental sounds, or any other auditory stimulus. This is weird. Your brain is expensive to run. It's 2% of your body weight, but burns 20% of your calories. Evolution doesn't waste that kind of energy on frivolous light shows. Every pattern of activation serves a purpose, solving some survival problem. So what problem does music solve that requires simultaneous activation of emotional centers, motor planning regions, memory systems, and predictive processing networks? Nobody knows. Not fully. But we're starting to understand the mechanics of the mystery. Let's start with emotion. Why does music make you feel things? The answer involves a tiny cluster of neurons deep in your brain called the nucleus accumbens. It's part of your reward system, the same network that responds to food, sex, drugs, anything your brain interprets as valuable for survival. When you hear a song you love, especially at the moment it hits that perfect note, that unexpected chord change, that crescendo you've been waiting for, Your nucleus accumbens releases dopamine. Dopamine is the neurotransmitter of anticipation and reward. Not pleasure exactly, but the feeling of, yes, this is exactly what I needed. And here's the fascinating part. Music triggers dopamine release in two distinct phases. First, during anticipation, as your brain predicts what's coming next. Second, at the moment of resolution, when your prediction proves correct or gets beautifully violated in just the right way. This is why familiar songs feel good. Your brain knows what's coming, builds anticipation, then rewards you when the expected note arrives. But it's also why unexpected variations feel even better. When a skilled musician takes a familiar melody and adds a surprising twist, your brain experiences a double reward. The satisfaction of recognizing the familiar pattern plus the thrill of the novel variation. Researchers have measured this. They put people in brain scanners, played them music, and watched dopamine spike at moments subjects described as giving them chills. That physical sensation, the tingling up your spine, the goosebumps on your arms. That's your brain's reward system firing so strongly it creates physical sensations. You get chills from music the same way you get them from life or death situations, because your brain is treating music like it matters for survival, like it's encoding information crucial to your existence. But why these specific emotions? Why do major chords sound happy and minor chords sound sad across virtually every human culture? The traditional answer is cultural conditioning. We learn these associations. But that doesn't explain why the pattern holds true in isolated cultures that developed their music independently. It doesn't explain why even young children, before significant cultural conditioning, respond to major and minor keys the same way adults do. Some researchers think the answer lies in the acoustic properties of human emotional vocalizations. When we're happy, our voices rise in pitch and take on harmonic patterns similar to major keys. When we're sad, our voices drop and develop acoustic properties similar to minor keys. Music, in this view, taps into evolved emotional recognition systems, ancient neural circuits for interpreting whether the person making sounds is friend or a threat, happy or distressed. Your brain hears a minor key and thinks, sad human voice. It responds with empathy, with emotional resonance, the same way it would respond to an actual distressed person, except there's no actual person. Just organized sound waves triggering emotional responses that evolve to facilitate social bonding. Then there's rhythm. Music's ability to make your body move without conscious decision. This isn't metaphorical. Rhythm literally synchronizes your neural firing patterns to external beats. When you hear a steady drum beat, neurons in your motor cortex start firing in sync with the rhythm, even if you're not moving. Your brain is preparing for movement, tracking the beat, predicting where the next one will land. Brainwaves in different regions begin oscillating together, creating what neuroscientists call entrainment. This matters because neural synchronization is how separate brain regions communicate. When two areas need to work together, their neural oscillations align, allowing information to flow efficiently between them. Rhythm drives this synchronization across your entire brain, linking auditory processing to motor planning to emotional centers to memory systems. But it doesn't stop at your individual brain. When multiple people hear the same rhythm, their brain waves synchronize not just internally, but with each other. This has been measured. Get a dozen people in a room, have them listen to rhythmic music together, put EEG sensors on their heads, and watch their brain waves begin pulsing in unison. This is how music creates group cohesion, not through abstract emotional resonance, but through literal neural synchronization. Your brain and their brains falling into the same patterns, oscillating together, temporarily functioning as a distributed processing network. Armies have known this forever. march, soldiers to drums, and their brains synchronize, making coordinated movement easier, making the group feel like a unit. Religious traditions discovered it independently across the world. Rhythmic chanting, repetitive hymns, synchronized swaying, all creating neural entrainment that makes individuals feel connected to something larger than themselves. But here's where it gets really strange. Some people have musical abilities that suggest their brains are wired differently from birth. Musical savants, often people with autism or developmental disabilities, who can hear a complex piece of music once and play it back perfectly, or who can improvise elaborate multi-voice fugues without any formal training, or who experience sounds as colours, numbers as melodies, synesthetic blending of senses that suggests unusual neural connectivity. The most famous case is probably Leslie Lemke, blind from birth, severe developmental disabilities, who heard Tchaikovsky's Piano Concerto No. 1 on television at age 14 and immediately played the entire piece perfectly, despite never having touched a piano before. Or Derek Paravicini, born premature and blind, who at age 2 could play back elaborate melodies. After a single hearing, and who now performs concerts despite profound cognitive disabilities in other areas. These cases tell us something crucial. There are dedicated neural structures for music, not regions that evolved for something else and got co-opted, but actual brain architecture specifically designed for processing, producing, and understanding organized sound. Neuroscientists have identified some of this architecture. The superior temporal gyrus contains neurons that respond only to specific musical features, sequences of notes, harmonic progressions. The planum temporale, larger in musicians than non-musicians, seems specialized for processing musical structure. The arcuate fasciculus, a bundle of nerve fibers connecting auditory and motor regions, is more developed in people with musical training, suggesting it evolved specifically to link sound perception with sound production. This is hardware, not software. These aren't general-purpose processing regions that learned music as a byproduct of other tasks. These are specialized systems, suggesting music has been important to human survival for long enough that natural selection has built dedicated neural machinery for it. But perhaps the most profound evidence comes from the opposite end of the cognitive spectrum. Alzheimer's patients who've lost almost everything, who don't recognize their children, who can't remember their own names, often retain musical memory long after everything else is gone. The musical memory is stored differently than other memories. It seems to involve structures that are among the last to degenerate. The supplementary motor area, the anterior cingulate, the inferior frontal gyrus, regions that remain relatively intact even in advanced Alzheimer's. Neurologists use this therapeutically now. Music therapy for dementia patients, using familiar songs from their youth to unlock islands of preserved personality, to briefly bring back the person who seemed lost forever. A woman who hasn't spoken in months will suddenly sing along to a song from her childhood. A man who doesn't recognize his wife will remember their wedding when he hears their first dance song. The music reaches something deeper than explicit memory, something more fundamental than the facts and faces that Alzheimer's destroys. It reaches whatever part of us remains constant through decades of life, the neural substrate of identity itself. This suggests music isn't just entertainment. It's not just a pleasant byproduct of language abilities or auditory processing. It's woven into the fundamental architecture of human consciousness, so deeply embedded in our neural structure that it survives even when almost everything else is gone. Your brain doesn't just process music, it's built for music, shaped by it, structured around it, dependent on it in ways we're only beginning to understand. The question is why? Why would evolution invest so heavily in neural architecture for organized sound? What survival advantage could possibly justify the massive neural resources dedicated to music? The answer might lie in what music does that nothing else can. It synchronizes groups, encodes information in memorable patterns, creates emotional bonds between individuals, and maintains social cohesion across space and time. Or maybe the answer is simpler, maybe more profound. Maybe music came first, before language, before symbolic thought. Maybe music is how our ancestors first learned to think about things that weren't immediately present. Maybe melody was the first abstract thought. Maybe your brain isn't built for music. Maybe music is what built your brain. Here's something that should keep you awake at night, even though we're trying to help you sleep. Music and language are processed by different parts of your brain. You can damage one ability and leave the other intact. They feel completely different when you experience them. And yet, the deeper researchers look, the more similarities they find. So many similarities that some scientists think we might be looking at the same thing, just split apart somewhere deep in our evolutionary past. Start with the structure. Language has syntax, the rules that govern how words combine into meaningful sentences. You can't just throw words together randomly and expect to be understood. The cat sat on the mat means something. Mat the on sat cat thee is gibberish, even though it uses the same words. Music has syntax too. Notes combine according to rules that vary across cultures but exist everywhere. In Western music, certain chord progressions feel resolved, complete. Others create tension, expectation. Play someone a major scale and stop on the 7th note. Their brain screams for you to resolve to the 8th. That's musical syntax, as rigid in its way as grammar. Both systems use hierarchical organization. In language, letters form words, words form phrases, phrases form sentences, sentences form paragraphs. Each level has its own rules, its own logic. Music works the same way. Individual notes combine into motifs, motifs into phrases, phrases into sections, sections into complete compositions. You can analyze a Beethoven symphony the same way you diagram a complex sentence, finding nested structures within structures, patterns within patterns. Both use rhythm and timing to create meaning. In language, the difference between "I didn't say he stole the money" with emphasis on different words changes the entire meaning. In music, the same notes played with different rhythms create completely different emotional effects. A march and a waltz can use identical pitches but feel nothing alike because of their rhythmic organization. So which came first? That's where things get interesting and controversial. For most of the 20th century, the assumption was obvious. Language came first, obviously. It's more complex, more useful for survival, more uniquely human. Music must have evolved, later probably as some sort of elaboration on language, maybe as a way to make important information more memorable, or to strengthen social bonds, or to attract mates. Music as a side effect, a bonus feature that piggybacked on language. But that assumption started crumbling when researchers began studying how babies develop. Because here's what happens. Newborn infants, just days old, respond to musical patterns before they respond to linguistic ones. Play a melody for a baby and change one note. They notice. They show surprise, interest. Their brains are already processing musical structure, recognizing patterns, detecting violations. And they're doing this before they've learned a single word. By 6 months, babies can detect rhythmic patterns in music that adults who weren't exposed to those rhythms as infants can no longer hear. A 6-month-old Japanese baby and a 6-month-old American baby can both detect offbeat rhythms in both Japanese and American music. But by 12 months, each baby has specialized. The Japanese baby has lost sensitivity to the American rhythms. The American baby no longer catches the Japanese patterns. They're learning to hear the music of their culture, just as they're learning to hear the phonemes of their language. But here's the crucial detail. The musical specialization happens first. Babies lock into the rhythmic patterns of their culture's music before they lock into the phonetic patterns of their language. They become musical natives before they become linguistic natives. This suggests that whatever brain systems process musical patterns, they might be more fundamental, more deeply wired than the systems that process language. And there's more evidence. Look at what happens when the brain gets damaged. Neurologists have documented cases of people who lose the ability to produce or understand language, a condition called aphasia, but retain perfect musical abilities. They can't speak, can't understand spoken words, but they can still sing, still recognize melodies, still feel emotional responses to music. There are cases of trained musicians who suffer strokes that destroy their language centers. They lose the ability to talk about music, can't remember the names of notes or chords, but sit them at a piano and they play perfectly, improvising complex pieces without conscious thought. Then there are the reverse cases, people with amusia or tone deafness. They can't recognize melodies, can't tell if someone's singing off key, can't detect when a familiar song is being played in a different key. But their language abilities are completely normal. They speak fluently, understand complex sentences, use grammar perfectly. Music is broken, language works fine. These cases tell us something profound. Music and language can be separated in the brain. They use overlapping but distinct neural circuits. Damage one and you can leave the other intact. But that doesn't mean they don't share a common origin. In fact, the overlapping circuits might be the remnants of something older, something that preceded both. Enter the musolanguage hypothesis. Proposed by neuroscientist Stephen Brown in the 1990s, it suggests that music and language evolved from a single proto-communication system used by our ancestors. A system that had features of both music and language but was fully neither. Imagine communication that was more melodic and emotionally expressive than modern speech, but less structured and precise than modern music. Something in between, something that served both functions at once. The idea is that as human populations grew and social complexity increased, communication had to split. Language evolved to become more precise, more capable of conveying specific factual information quickly. Music evolved to become more emotionally powerful, more capable of creating shared feeling states in groups. Both emerged from the same source, like twin rivers splitting from a single spring. This would explain why they share so many structural features, why babies process musical patterns using the same brain regions they'll later use for language, why the two systems can be separated by brain damage but still show so much overlap in healthy brains. They're not two completely independent inventions, they're two specializations of a single, older system. And there's evidence for this in the structure of certain languages still spoken today. Tonal languages like Mandarin Chinese, Thai, Yoruba, where the pitch at which you say a word changes its meaning completely. The Mandarin word mai can mean mother, hemp, horse, or scold, depending entirely on the tone. Get the pitch wrong, and you're talking about a completely different thing. This isn't music, and it isn't quite language in the Western sense. It's both at once, a communication system where melody carries semantic meaning. Speakers of tonal languages show different brain activation patterns when speaking than speakers of non-tonal languages. The musical processing centers light up during normal speech. They're literally singing their words, using melody to convey meaning, blurring the line between music and language every time they talk. And it's not just tonal languages. All language has prosody, the melodic contours that convey emotion and emphasis. You're coming to dinner can be a statement, a question, or a threat. depending entirely on the melody of your voice. The words are identical, the musical contour changes everything. We're all using music when we speak, we just don't notice it because the musical elements are subordinate to the linguistic content. But they're there, embedded in every conversation, every argument, every declaration of love. Maybe our ancestors used this musical linguistic hybrid more equally. Maybe their communication was more like song, with precise melodic patterns carrying as much meaning as the sounds themselves. As social groups grew larger, as the need to convey complex information increased, maybe language gradually became more focused on precision and less on melody. The musical elements didn't disappear, they just became secondary, moved into the background. But they never went away completely, and in certain contexts, they come roaring back. Consider what happens when you combine lyrics and melody into song. The words alone might be simple, maybe even banal. Yesterday, all my troubles seemed so far away. It's not great poetry, just a simple observation. The melody alone might be pleasant but not particularly meaningful, just a sequence of notes. But combine them and something magical happens. The melody gives the words emotional weight they wouldn't have on their own. The words give the melody specific semantic content it couldn't convey alone. Together they create something that hits you in both the language centers and the music centers of your brain simultaneously. This is why lyrics are so hard to write well. You're trying to satisfy two different systems at once. The words need to work linguistically, conveying meaning, telling a story. But they also need to work musically, fitting the rhythm and melody, creating sounds that enhance rather than fight the musical content. Great lyricists are essentially bilingual, fluent in both language and music, able to move between both systems seamlessly. And when they get it right, when lyrics and melody align perfectly, the effect is more powerful than either could achieve alone. The words make the music mean something specific. The music makes the words feel like truth. Your linguistic brain understands what's being said. Your musical brain feels it emotionally. And somewhere deep in your neural architecture, maybe in circuits that your ancestors used hundreds of thousands of years ago, the two streams of information merge back into something unified. Something that feels completely natural, even though modern humans have separated it into two distinct systems. This might be why music with lyrics feels so compelling, why we remember songs more easily than speeches, why advertising jingles stick in your head for decades while you forget what someone told you yesterday. You're not just processing language or music, you're accessing something older, something more fundamental, a communication system that predates the split between speech and song. But we're still guessing, still piecing together fragments of evidence, trying to reconstruct what happened in the minds of people who lived too long ago to leave direct evidence. Did they sing before they spoke? Did they do both at once? Did something even older than either music or language give birth to both? The answer is hiding somewhere in the structure of your brain, in the way babies process sound, in the songs you can't get out of your head. Twins separated at birth, maybe. Or maybe just one child that learned to speak with two voices. Imagine this. You're lying in the dark, somewhere on Earth, but you don't know where. You can't see the stars, you can't smell the plants. You don't know the language of the people around you. You don't know what continent you're on, or what century it is. All you have is sound. Around you, people are making music. No instruments you recognize, no words you understand, but still, you know things. You can tell when the music is for dancing, even if you don't know the dance. You can tell when it's meant to soothe a baby, even if you've never heard that melody before. You can tell when it's about love or grief or worship, even if the lyrics are a mystery. Your brain just knows. That feeling, that strange sense of recognition inside unfamiliar music, isn't an illusion. It's a clue a trace of something deep and shared, running through every human group that has ever existed. In the last few years, scientists have started to map that shared territory, not metaphorically, literally, cataloguing songs the way biologists catalogue species, looking for musical universals the way geneticists look for genes. And what they're finding is that, under all the cultural variation, the world's music is not a chaotic mess of arbitrary sounds. It is structured, predictable, constrained. Like language, it can say an infinite number of things in an infinite number of ways, but it seems to be built from the same underlying toolkit, everywhere humans have ever lived. In 2019, a group of researchers published something quietly extraordinary. They called it the natural history of song. For years, they had been assembling what amounts to a musical fossil record of our species. Not just recordings from Spotify and radio stations, but field recordings from remote villages, ethnographic archives, wax cylinders from a century ago. They sifted through thousands of descriptions from anthropologists and travellers. They documented who sang, when they sang, why they sang. Then they did something else. They listened like scientists. They stripped away the stories, the costumes, the instruments, the languages. They turned the songs into numbers, pitch intervals, tempos, rhythmic patterns, melodic contours, and asked a simple question. When humans make music anywhere on Earth, do we keep doing the same basic things? Or is every culture's music its own separate invention, like a private language with no shared grammar? They didn't know what they were going to find. A lot of people expected chaos. Western scales here, Indian ragas there, throat singing in one place, yodeling in another, different rules, different aesthetics, different conceptions of what music even means. But that's not what the analysis showed. The deeper they dug, the more they kept finding the same patterns, over and over. In hunter-gatherer societies and agricultural empires, in Arctic villages and equatorial forests, on islands, in cities, in places that had been separated for tens of thousands of years. The details were wildly different. The foundations were not. Start with one of the most mysterious ones, octave equivalents. If you double the frequency of a note, if it vibrates twice as fast, most human ears hear that new sound as somehow the same note, just higher. An A at 110 Hz and an A at 220 Hz feel related, almost like a parent and child. Different, but belonging together. This is not an obvious way to experience the world. Nothing in physics says that a doubling of frequency has to feel special. To a computer, 110 and 220 are just numbers. To a dog, they're just two different pitches. But to humans, in almost every musical tradition on Earth, tones separated by an octave are grouped as equivalent. They share a name, a role, a place in the scale. We stack octaves like floors in a building. We build ladders of pitch that repeat every time we double the frequency. Some cultures divide the octave into 5 steps, some into 7, some into 12, some into 24 microsteps so tiny most Western-trained ears can barely hear them. But almost everyone is climbing the same invisible spiral. The octave is the loop. We don't know exactly why the brain treats it that way. It might come from the way our auditory system organizes frequencies. It might be a side effect of neural wiring meant for something else entirely. But whatever the origin, the pattern is there, over and over, from the forests of the Congo to classical Beijing opera. The Natural History of Song team found that when people sing, they almost always use pitches that fall into small, simple ratios within an octave. They rarely leap by huge, awkward intervals. They move by steps and small jumps like walking rather than teleporting. You can think of it this way. Out of the infinite possibilities of sound, human music lives in a small, carefully fenced garden. We keep choosing the same paths through that garden, no matter which continent we're on. Rhythm tells the same story. If you tap along to a song anywhere on Earth, you'll almost never find yourself tapping in some bizarre, irregular pattern that never repeats. Instead, your hand falls into cycles, groups of 2 or 3 or 4 or combinations of those, left, right, or 1, 2, 3, 1, 2, 3. Music, almost everywhere, is periodic. It has a pulse. That doesn't mean it's simple. West African drumming can weave polyrhythms so intricate they feel like braided time. Balkan folk music dances in complex meters that twist and turn. Indian classical rhythms can span cycles so long you lose track if you're not trained. But under all the variation, there is regularity. Patterns repeat. Beats are grouped. Tempo, that is, how fast the beat is, falls within a surprisingly narrow range, especially for songs meant to be sung or moved to by ordinary people. Humans don't sing lullabies at 12 beats per second or dance to music that feels like geological time. Our bodies impose constraints, heart rates, breathing rhythms, walking pace. Somewhere between too slow to track and too fast to coordinate, there's a natural window where music lives. The Natural History of Song project found that across cultures, listeners can often tell whether a song is meant for dancing, healing, or soothing a child, just by hearing a short clip. The language doesn't matter, the instruments don't matter, the meaning rides partly in the rhythm. Dance songs, almost everywhere, are faster, more regular, stronger beat. You can feel the invitation to move in your legs before you consciously decide anything. Lullabies slow down. They soften. Phrases stretch. The pulse becomes gentle and rocking, like the rhythm of being held. Healing songs, those used in rituals, shamanic ceremonies, exorcisms, tend to be repetitive, trance-inducing, full of cycles that go on, drawing attention inward or upward or away from ordinary time. We're not just hearing sound. We're reading the nervous systems of the people who made the sound and the bodies they were aiming at. Feet, babies, patients, lovers, gods. Now zoom out even further. Forget pitch intervals, forget tempo. Ask a simpler question. When humans make music, what are they using it for? Across 315 societies, the Natural History of Song team catalogued the functions of music. Not the genres in a Western sense, but the purposes. What role each song played in daily life. They expected to find some overlap and a lot of uniqueness. But once again, the pattern was clearer than they guessed. Every documented culture on record has something like lullabies, dance songs, healing or ritual songs, love songs. Not just lots of songs that happen to be about love in some vague way. Specific musical behaviours, songs used to court, to express longing, to bind couples. Songs used to soothe infants. Songs used to coordinate movement. Songs used in ceremonies intended to change physical or spiritual states. The melodies differ, the words differ, the instruments differ, the rules of harmony and dissonance differ, the functions don't. This is like discovering that every language on earth has words for mother, water, and you, even if the sounds are completely different. It suggests common problems every human group has to solve, and common solutions our brains keep reinventing. Take lullabies. Wherever you go, they tend to be quieter, slower, simpler melodically, narrow in range, few wild leaps up and down, often repetitive with gentle contours that rise and fall like breathing. You could say that's obvious. Of course you don't scream at a baby in 7-8 meter. But the fact that it's obvious is the point. It's written into what brains do. Mothers in different cultures, given a made-up melody and a pretend crying baby, will instinctively slow the melody down, soften the voice, narrow the range, smooth the rhythm. They turn almost anything into something lullaby-like. Dance music shows the same convergence from the other side: strong beat, pronounced pulse, clear structure, the details of how you move, whether you're doing a Sufi whirling ceremony, a TikTok dance, or a sword dance in the Scottish Highlands, may differ radically. But underneath, the music is telling muscles when to contract and relax in synchrony with other bodies. Healing and religious music cluster together as well. They often live in the liminal spaces between speech and song. Chants, incantations, hymns. Repetition becomes central. Certain intervals or timbres become associated with altered states. Drums mimic heartbeats or break them. Voices rise and fall in ways that can pull listeners into shared emotion or shared trance. Love songs, too, bear a signature. They're not just slow or romantic in the Western sense. Cross-culturally, they often feature expressive pitch slides, slight variations in timing, the musical equivalent of a trembling voice. They linger, they bend, they pull time around emotion. None of these are strict rules. You can find exceptions in any culture, but as you average across hundreds of communities, across continents and centuries, the similarities stand out more than the differences. It's as though humans everywhere are drawing from the same palette: tempo, rhythm, pitch range, repetition, timbre. And we keep combining those colours in similar ways when we face the same problems: putting a baby to sleep, gathering a group to move as one, courting a mate, asking unseen powers for help. What does this say about the mind that makes the music? It suggests that musical cognition, the way the brain organises sound into something we call music, is not blank and open-ended. It's a specialised system, tuned by evolution, with built-in expectations. Babies only a few months old already track regular beats. They notice when a rhythm breaks the pattern. They prefer consonant intervals, simple frequency ratios, over harsh, clashing ones. They recognise lullaby-like melodies as soothing, even if they've never heard them before. Exposed to the music of their own culture, infants quickly learn its specific rules: which intervals are allowed, which rhythms are common, what in tune means in their community. But they start from a set of broad, species-typical priors. Music has a pulse, notes fall into steps, octaves match. Repetition matters. The natural history of song researchers found that people unfamiliar with a culture's music could still make above-chance guesses about what that music was for. They could pick out the lullabies, the dance songs, the healing chants, the love songs, just by listening. That doesn't happen if musical meaning is entirely arbitrary. It's more like speech prosody, the melody of spoken language. You might not understand the words of a stranger's language, but you can usually tell if they're angry or soothing or asking a question. The shape of the sound carries a kind of meaning that rides above grammar. Music seems to be an amplifier and elaboration of that system, an art form built from tools our brains were already using, taken farther than speech alone. And yet, if we stopped here, the story would be too simple. Because for all the universals, the differences are real, and they matter. Listen to a Tuvan throat singer, a Balinese gamelan, a Navajo healing chant, a Bach cello suite, a Bollywood hit, a Japanese gagaku ensemble. You're hearing the same species, using the same cognitive machinery, solving many of the same problems. You're also hearing very different answers to the question: what counts as beautiful, meaningful sound? Some cultures favour scales with 5 notes. Others use 7 or 12, or microtonal systems that split the octave into dozens of tiny steps. Some love dense, complex harmonies. Others prefer bare, open intervals. In some places, a perfect fifth is sacred. In others, it's just one colour among many. no more special than any other. Some traditions build instruments out of metal and wood, others sing into the wind or beat the earth, or use only the human body as drum and flute and resonating chamber combined. Even the boundaries of what counts as music shift. In some societies there is no separate word for it. There is only song or dance or prayer. The Western habit of pulling music out as an independent object, something you can stream, buy, consume alone in headphones, is historically recent and culturally specific, and tastes change. What one generation finds harmonious, the next can find dull. What one era bans as dissonant and immoral, another celebrates as genius. Ears are plastic. Culture teaches the brain what to expect, and expectation reshapes pleasure. To a medieval monk, a jazz chord might have sounded like chaos. To someone raised on complex jazz harmonies, a simple Gregorian chant might feel too spare. The underlying cognitive toolkit is the same, but the learned settings are different. This is the paradox at the heart of human music. There are stable universals, octaves, small intervals, rhythmic regularity, functional categories like lullabies and dance music that point to a shared biological foundation. And there is virtually infinite variation on top, systems of tuning, timbre, rhythm, form that can spiral outward in a million cultural directions. Music is both a human inheritance and a cultural invention. It's like language. Every child is born with a brain expecting to learn one, but which language they learn, which sounds they consider meaningful, depends on where and when they're born. A baby in ancient Mesopotamia, a baby in modern Tokyo, a baby in 10,000 BCE on the African savannah, they all brought roughly the same auditory hardware to the world. The songs that hardware helped build were different, but not random. So what does all of this mean for the mystery we started with? It tells us that music isn't a byproduct of civilization, or a luxury, or an accident of culture. It's not something a few societies happen to invent while others could have gone without. Wherever there are humans, there is music. Wherever there is music, it follows certain rules. And wherever it follows those rules, it ends up doing similar jobs in human lives. Soothing, synchronizing, seducing, healing, praising, remembering. This is exactly what you'd expect if music, like language, rode out that ancient bottleneck and came through the fire of near extinction, not as decoration, but as part of the core survival kit. Brains that could group sound into octaves, feel a shared pulse, sense the intention in a melody. These brains could be soothed more easily, could move together more effectively, could bond, mourn, celebrate, and coordinate in ways that scattered, survival-tested groups desperately needed. Over hundreds of thousands of years, those brains shaped cultures, and those cultures shaped the specific forms of song, building gamelans and choirs and flutes and drums out of the same deep grammar. When you listen to a song from a culture you've never encountered before and feel something click in your chest, that's what you're meeting. Not just the individual composer, not just the local tradition, but a pattern of sound your ancestors have been playing with for as long as we have been human. Music is the most ancient inside joke we still all get, even if we don't know why we're laughing, or crying, or dancing. Tonight, as you drift towards sleep, the world outside your window might feel quiet, but somewhere, a mother is humming to a baby. Somewhere, a circle of people is moving in step around a fire. Somewhere, a healer is chanting over a patient. Somewhere, someone is singing about love they have, or love they've lost. Different languages, different gods, different instruments carved from different trees, the same species, the same nervous systems, the same inherited sensitivities to pitch, pulse, and pattern. Music is our universal passport and our local accent at the same time. It is the part of us that is oldest and most shared, dressed up in the colours of each particular place and time. Our ancestors carried this capacity through the bottleneck, through the ice and drought and hunger. They used it to mark belonging and remember, to keep babies calm and hunters coordinated, to turn fear into courage and grief into something bearable. We may never know exactly when the first song was sung or what it sounded like, but when we listen across cultures and across time, the echo's clear. Whatever that first song was, it left fingerprints on every song that came after, a scale that repeats, a beat that returns, a voice that rises and falls in ways a human heart can understand, even in the dark, even half asleep, even when we have no words at all. And from that shared grammar of sound, humans have spun an endless, branching, shimmering library of musics, each one different, each one unmistakably human, a universal pattern, an infinite variation, a clue waiting to be followed deeper into the mystery of why we sing at all. Picture this. You're lying in the dark of a cave 40,000 years ago. A fire is burning low. Shadows flicker on the walls, turning painted animals into moving spirits. Around you, people are silent. Then you hear it. A slow, steady drum. Maybe it's a hollow log or a stretched piece of skin. Maybe it's just hands on a stone floor. But the beat is regular, insistent, like a second heartbeat laid on top of your own. Boom, boom, boom. At first, it's just sound. Then your breathing starts to match it. Your heart rate shifts without you deciding anything. The edges of your thoughts begin to blur. You're not quite awake in the ordinary sense anymore, but you're not asleep either. You feel suspended between worlds. The drumming doesn't stop. Someone begins to chant. The words don't matter, or maybe there aren't any words yet, just rising and falling tones. The sound moves through your body. You feel like the cave is breathing with you. The painted bison on the walls stop being drawings and start becoming presences. For your ancestors, this was not a concert. This was a doorway. Across cultures, across millennia, humans have discovered the same strange fact. If you repeat sound in the right way, at the right tempo, in the right space, human consciousness changes. Time stretches. Boundaries soften. People see visions, feel presences, receive messages they interpret as coming from gods, spirits, ancestors, or some vast impersonal mystery. This is where music stops being just pleasant noise and becomes something else, sacred sound. Music as the technology of the divine. Anthropologists who study hunter-gatherers notice something curious. When you strip away cities, writing, organized religion, almost everything we think of as civilization, one thing remains nearly universal: rituals with sound. In Siberia, a shaman sits alone in a yurt, beating a drum at a very specific tempo. In the Amazon, a healer drinks a bitter plant brew and sings long, winding melodies that seem to go nowhere and everywhere at once. In Africa, a circle of dancers moves around a fire while drummers lock into interlocking rhythms so complex that no single person can count them, but the group can feel them. These cultures are separated by thousands of miles and tens of thousands of years of independent history. Yet the patterns rhymed, steady, repetitive drumming, vocals that hover between speech and song, dances that sync multiple bodies into one coordinated movement, long durations, darkness, or at least low light, and always a shared belief. The sound does something. To our ancestors, this wasn't metaphorical. The drum didn't just symbolize the heart of the earth, it was the heart of the earth. The chant didn't just represent an ancestor, it was the ancestor, made audible again. Modern neuroscience has fancy words for what's happening here. Entrainment, neural synchrony, rhythmic stimulation of the thalamocortical loops, brainwaves shifting into slower frequencies associated with trance and deep meditation. But your ancestors didn't need EEG machines to notice the effect. They just had to sit in the dark and listen until their sense of self loosened, and something vast, terrifying, and beautiful seemed to open up in the space the drum was carving out of silence. Imagine being the first person to discover this. You're in a small band of foragers, life is precarious, the weather is unpredictable, animals appear and vanish with no warning. People fall sick, recover, or die for reasons no one understands. You pick up a hollow piece of wood and start tapping, not randomly. You find a pulse that feels right in your chest. Others start humming with you, almost without thinking. The children sway. Someone starts to cry for no obvious reason. Someone else starts laughing. Afterwards, people say they feel lighter, clearer, like something heavy has been shaken loose. In a world where everything is alive and nothing is explainable, how do you interpret this? Of course it feels supernatural. Of course it feels like a power. Over time, the people who are best at working with this power became specialists. We call them shamans, medicine men, healers, seers, priests, priestesses. But underneath all the cultural details, the job description had a strange consistency. They were sound workers. They knew which rhythms made people calm, which ones made them ecstatic, which ones made them feel like they had left their bodies and travelled to other realms. They learned which melodies helped a woman in labour, which chants steadied a dying person, which songs stitched quarrelling families back together. If language was the technology that let humans coordinate daily life, sacred music was the technology that let them coordinate inner life. The chaotic private world of fears, dreams, and longings suddenly had a shared soundtrack. Fast forward. The cave paintings have long since faded. The small bands of foragers have become villages, then towns, then city-states. Temples rise. Kings claim to rule by divine right. And somewhere in southern Italy, around 2,500 years ago, a strange man is listening to the stars. His name is Pythagoras. Legend says he wouldn't eat beans, believed in the transmigration of souls, and thought numbers were the ultimate reality. But what matters for our story is this. Pythagoras believed music was not just an art. It was a blueprint of the cosmos. According to later reports, he discovered that the most pleasing musical, intervals, octaves, fifths, fourths, could be produced by strings whose lengths were simple numerical ratios, 2:1, 3:2, 4:3. The prettier the sound, the simpler the math. To him, this wasn't a curious coincidence, it was evidence. If the ear was most satisfied by simple ratios, and if those ratios could be expressed as numbers, then the universe itself might be constructed according to some hidden musical code. Planets, he thought, might be spaced according to harmonic proportions. Their movements through space might produce a vast inaudible harmony he called the music of the spheres. Later, philosophers took this idea and ran with it. Plato, centuries after Pythagoras, would say that studying music, proper, mathematically ordered music, trains the soul to perceive the invisible order behind chaos. To them, sacred sound wasn't just about entering trance. It was about aligning the human mind with an objectively existing cosmic order. Today we don't talk about the music of the spheres in quite the same way. But when physicists describe the universe in terms of vibrations, frequencies, and resonances, they are, in a way, still speaking the language Pythagoras helped invent. Underneath the myth and mysticism, there's a simple intuition. The world is not random noise, it has structure, pattern. And the human nervous system is built to feel those patterns most directly through sound. While Greek philosophers were tuning their lyres to mathematical ratios, something very different, but strangely related, was unfolding in other parts of the world. In the deserts and cities of the early Islamic world, a new ritual sound emerged, not instrumental, not mathematical in the Pythagorean sense, but vocal, soaring, charged with devotion. The call to prayer. 5 times a day, a human voice would rise from minarets, stretching out long, melismatic phrases that curved and spiraled through the air. For believers, this wasn't just a reminder to pray. The sound itself was a thread weaving their day into cosmic time. It turned ordinary hours into sacred hours. In echoing stone churches of medieval Europe, monks developed something similar but with its own logic. Gregorian chant. No harmony in the modern sense, no pounding rhythm. Just a single melodic line flowing slowly, almost weightless, hovering around a narrow range of notes. The point wasn't personal expression. It was the opposite. You dissolved your individuality into the collective voice, which was itself meant to be a vessel for something beyond human emotion. Chant long enough in a dimly lit stone corridor, and acoustics do the rest. The sound smears and blends. The line between where your voice ends and the others begin starts to blur. You can't tell if the note you're hearing is coming from out there or in here. In Hindu temples, ragas evolved. Complex melodic frameworks tied to times of day, seasons, even specific deities and moods. A raga at dawn wasn't just a nice song to start the morning. It was a way of tuning human consciousness to the particular flavour of that slice of time. In Buddhist monasteries, monks recite sutras in rapid, rhythmic patterns, or hold deep, droning chants for what seems like hours. The goal is not entertainment, it's transformation of mind. The repetitive sound is a tool to still the usual chatter and let a different kind of awareness emerge. Different theologies, different histories, different instruments. But underneath the variety, the same intuition whispers, if you shape sound a certain way, you're not just passing time, you're touching something sacred. Why does this work? Why can a drum in a cave, a monk in a cloister, a muezzin on a minaret, a sitar player in Varanasi, and a chanting monk in Tibet all produce such similar reports of altered states? Timelessness, unity, peace, awe, visions, using nothing more than patterned air vibrations. Part of the answer is brutally simple. Your brain is an electrical organ. At any given moment, billions of neurons are firing in complex patterns. These patterns can synchronize into waves at different frequencies, fast for active thinking, slower for drowsiness and meditation, even slower for deep sleep. When you expose this system to repeated external rhythms, clapping, drumming, chanting, some of those internal rhythms can lock onto the outside beat. This is entrainment. It's why you tap your foot without meaning to. Why groups march more easily than they walk alone. Why a lullaby can calm a crying baby. Why a heartbeat at 60 to 80 beats per minute feels comforting. Why 4-8 beats per second, translated through certain rhythmic patterns, can nudge your brain toward the slow, trance-like states just above sleep. From the inside, this doesn't feel like neural oscillatory synchrony. It feels like the world has shifted. Your normal sense of me's here, now begins to loosen. Your awareness becomes diffuse, more open to imagery, to suggestion, to emotion. In a supportive setting, darkness, community, a guiding ritual, you're more likely to interpret this softening not as a glitch, but as an opening to spirits, to God, to emptiness, to the ancestors, to the universe. Different cultures fill the blank with different words. The underlying biology, though, seems remarkably consistent. Rhythm is a handle on the nervous system. Music is how we grab it. This is why sacred sound almost never appears in isolation. You don't just drum for fun at a funeral and call it a day. You don't perform a raga on the birth of a child as random background noise. Wherever life pushes up against the boundaries of the known, birth, death, marriage, harvest, initiation, music shows up like a nervous system scaffold. A child is born. In many cultures, the first thing they hear beyond their mother's heartbeat and breath is song. A cradle song, a naming chant, a blessing melody. Sound wraps them before language does, introducing them to the human world. A young person reaches puberty. Their body is changing. Their role in the group is changing. It's frightening, confusing. Many societies develop initiation rituals, vision quests, seclusions, ordeals, all wrapped in sound. Drums that go all night, chants that repeat the stories of the ancestors. The message is clear. You're not going through this alone. You're being carried by a pattern older than you are. Two people marry. In nearly every culture, this transition is sung. Wedding songs, processional music, communal dancing. The individual pair bond is lifted into a web of relationships. The private vow becomes a public sonic event. Someone dies. Here, sacred sound often becomes its most intense and poignant. Laments sung in piercing, unsteady intervals. Soft, almost whispered psalms. Drums slowed to a heartbeat that is fading, then gone. Music at death does something words alone struggle to do. It acknowledges the unspeakable and gives it a shape we can feel together. Even the cycles of the land get soundtracks. A successful hunt. There is a song. A failed harvest. There is a song. Winter solstice. Summer monsoon. There are songs. In a world where survival depends on forces beyond human control, music becomes a way of negotiating with the unpredictable. You can't command the rain, but you can sing to it. In every case, the pattern repeats. When humans face moments that feel too big, too joyful, too painful, too mysterious for ordinary language, they reach for sound. Not random sound, organized sound, music. What does that tell us about why humans across time have insisted that music connects them to something greater than themselves? One possibility is purely social. When you sing with others, your breathing synchronizes, your heart rates start to line up, your brains begin to show similar patterns of activity. You are, quite literally, becoming one organism for a little while. The boundary between me and us thins. From the inside, that can feel like touching a larger presence. Not just a group of individuals, but a kind of super-person, a we that has its own life. Religions give that presence names. God, the Holy Spirit, the ancestors, the Great Spirit, Brahman. But the immediate bodily sensation is the same. I am not isolated. I am immersed. Another possibility is cognitive. Your brain is a pattern-hungry prediction machine. It is always trying to make sense of the chaos of reality by finding structure. Music is structure distilled, pitches arranged in scales, rhythms organized into meters, phrases with tension and release. When you listen to or make music, you're bathing your prediction machinery in a concentrated bath of pattern. Sometimes, when the patterns are especially rich, especially balanced between predictable and surprising, the system flips into a state of awe. The same feeling you might get looking up at night sky full of stars or standing at the edge of the ocean. Music can create that feeling indoors, in the dark, with your eyes closed. Is that God? Is that the universe? Is it just your brain rewarding itself for finding order in chaos? From a scientific perspective, we don't know for sure. From a human perspective, the labels may matter less than the experience itself. There's one more possibility, harder to pin down, but it haunts the edges of this story. What if music doesn't just create the feeling of connection to something greater? What if it's how we perceive that greater thing in the first place? Think of it this way. Your ancestors evolved eyes because there was something out there to see, light bouncing off objects, creating patterns that could guide behavior. They evolved ears because there was something out there to hear, pressure waves in air and water that carried information about predators, prey, storms, and friends. Now imagine that consciousness itself, whatever that is not entirely locked inside individual skulls. Imagine that your subjective experience is a tiny wave in some vast ocean of awareness, most of which you can't usually access. How would a creature like that learn to sense the ocean? Maybe through rhythm, through patterns that bypass language and go straight to the parts of the brain that dissolve boundaries, that quiet the inner narrator, that open up a sense of merging with something larger. In that scenario, sacred music isn't just entertainment or even just a social glue. It's a kind of sensory organ, a way of feeling the invisible connections that are always there but rarely noticed. This idea isn't testable in any straightforward scientific way. It lives in myth, philosophy, personal reports, but it won't go away. It shows up wherever humans have sat around fires, built temples, or lay awake at night listening to their own heartbeats and wondering what, if anything, was listening back. So, here we are. Modern humans, descendants of bottleneck survivors, carrying nervous systems tuned by 1,000,000 years of danger, cooperation, and pattern hunting. We have symphonies, pop songs, techno tracks, film scores, meditation playlists. We have subwoofers that shake our bones and tiny earbuds that whisper directly into our skulls. But under all the cultural layers, the same ancient circuitry is still there. The drum that can carry us into trance, the chant that can quiet the mind, the melody that can make us feel, if only for a few seconds, that we are not alone in a cold, indifferent universe. When a stadium of strangers sings the same chorus in unison, when a congregation falls silent as a single voice rises in prayer, when a newborn's crying slows and stops as someone hums a lullaby, when someone at the end of their life relaxes at the sound of a familiar hymn. In those moments, we are closer to our cave-dwelling ancestors than we might think. Music somehow crosses the gap between people, between moments of life, between the known and the unknowable. Whatever else it may be, evolutionary byproduct, social glue, cognitive training tool, music has been for as long as we can trace our favourite portal to the divine, however we choose to name it. And the mystery only deepens when we realise that, after all this time, we still don't really know why it works. We just know that, in every age, when humans have wanted to touch what feels like the sacred, they have closed their eyes and listened. The truth is, for all our theories, for all our data and brain scans and computer models, we still don't really know why music exists. We can tell beautiful stories about it. We can line up evidence, draw arrows on timelines, map out neurons lighting up when a melody plays. But when you strip away the confident diagrams and the tidy conclusions, you're left with something scientists don't always like to admit: a mystery. Not the kind of mystery that goes away when you look at it closely enough, the kind that gets deeper the more you learn. Like staring into clear water and realizing the lake has no bottom, you can see only darker and darker blue. Think about everything we've already covered tonight. The ancient flutes carved from bone, the echoes of rhythm in our heartbeat and our footsteps, the strange partnership between music and language, the way a simple tune can crack open the sealed vault of memory and let 60-year-old feelings spill out like they happened yesterday. Put all of that together and you'd think the answer would be obvious, but it isn't. Because every time researchers think they're closing in, every time a new brain imaging study or archaeological discovery seems to settle the question, another piece of evidence appears that doesn't quite fit. Another species that responds to rhythm when it shouldn't. Another human culture that breaks the so-called universal rules. Another patient whose damaged brain can't understand speech, but can still understand song. So as you lie there, maybe listening to the faint sounds of your own room, or the distant hum of a city, or the quiet breathing of someone asleep beside you, we're going to walk very gently into the territory of we don't know, because that too is part of the story. One of the biggest debates about music's origins is deceptively simple. Is music an adaptation or an accident? Did natural selection shape our brains specifically for music because those who could sing, drum and dance had more surviving children? Or is music a byproduct, a side effect of other mental abilities that were truly useful, like language, pattern recognition, emotional signaling, and we just happen to enjoy this weird cognitive leftovers buffet? On one side, you have the adaptationists. They argue that music is too costly, too complex, too universal to be an evolutionary fluke. Costly, because learning music takes time and energy. You have to build instruments, practice, devote hours to mastering rhythms and melodies. In the Pleistocene, those were hours not spent hunting, gathering, or guarding the campfire from predators. Complex, because musical understanding involves fine motor control, pitch discrimination, temporal precision, social coordination, emotional nuance. It's the cognitive equivalent of juggling flaming torches while balancing on a tightrope over a pool full of crocodiles. Universal, because there's no known human society without some form of music. It always shows up. It always matters. Adaptationists look at all this and say, evolution doesn't waste that kind of effort without a good reason. Music must have helped us survive. Maybe it bonded groups together, synchronized effort, calmed infants, signaled mate quality, or helped us remember important information. Maybe all of the above, maybe more we haven't even thought of yet. On the other side, you have the byproduct theorists. They say, wait, slow down, yes, music is powerful, yes, it's everywhere. But that doesn't mean evolution selected for it directly. Maybe music piggybacks on abilities that were selected for: language processing, motor coordination, auditory scene analysis, emotional resonance. Just like reading rides on top of our object recognition and language systems, even though nobody evolved specifically to decode ink on paper. In this view, music is like cheesecake. Our brains evolved to crave fats and sugars because they were rare and valuable in the ancestral environment. Cheesecake is an ultra-concentrated super stimulus that hijacks that ancient circuitry. Delicious, addictive, but not something natural selection planned. Music in the byproduct story is cheesecake for the mind, a super stimulus for pattern-loving, prediction-making, socially tuned brains. The problem is, both sides have good arguments, both can point to evidence, and right now the scales don't tip decisively either way. Some studies show that musical ability has a heritable component, passed down in families, which smells like adaptation. Other studies show that almost all the cognitive ingredients for music are shared with language and other domains, which smells like byproduct. So we circle, and we debate, and we gather more data, and the question remains on the table like a puzzle nobody can quite solve. Then there's the question of where music began, not geographically. We'll probably never know which patch of savanna or forest heard the first lullaby, the first hum of wordless comfort in the night. The question is deeper. Did music begin once, or many times? Imagine a single origin story. Somewhere, perhaps in a small band of bottleneck survivors huddled around a fire, one lineage stumbled upon the trick of turning organized sound into social glue. Their babies calmed faster when rocked and sung to. Their hunts went better when movements were synchronized. Their rituals felt more powerful when accompanied by rhythm and tone. Generation after generation that musical knack spread. It wove itself into every aspect of their culture, and as their descendants migrated to Ice Age Europe, to the high plateaus of Asia, across land bridges and along shorelines, it came with them, changing shape, but always there. The melody line of humanity passed from parent to child for hundreds of thousands of years. In this single origin picture, the universals of music, rhythm, repetition, scales, emotional expression, are echoes of that first cultural invention, fossilized not in bone, but in habit. But there's another picture. Maybe music didn't begin once. Maybe it began whenever and wherever conditions were right. Whenever some group of humans, or even pre-humans, had the brain power for pattern and prediction, the social need for bonding, and a few spare moments between hunger and fear. In this view, early Neanderthals in a frozen valley might have invented haunting vocal calls to coordinate hunts, completely independently of an African group using drummed rhythms to keep time while processing tubers. Denisovan sailors might have developed work songs to time the strokes of paddles as they crossed between islands. Different beginnings, different solutions, different musical worlds that only later began to mix. Multiple emergences would explain why some musical traditions on opposite sides of the world feel uncannily similar, while others sound like they come from entirely different planets. It might also explain why certain pieces of our brain respond to music in ways that look more like patched-together improvisations than a single, neat music module. Evolution tinkering again and again, reusing whatever was at hand. Single origin, multiple origins. A tangled mix of both. We don't know. We may never know, because songs don't fossilize. We're trying to reconstruct entire symphonies from scattered instruments buried in caves and a few worn grooves on ancient shells. So the debate continues, quiet and patient, moving forward at the speed of new findings, and the question, one melody or many, remains open. Future discoveries might help. They might not give us a final answer, but they can narrow the possibilities, like turning up the dimmer switch on a very old, very dark room. Genetics is one promising lantern. Already, researchers have found gene variants that affect how precisely you can perceive pitch, how easily you synchronize to a beat, how likely you are to experience chills when listening to music. If they can trace some of these variants deep enough into our past, if they can track them back to periods when music-like behavior appears in the archaeological record, then suddenly we're not just guessing. We might discover that a particular gene associated with rhythm perception spread rapidly around 200,000 years ago, suggesting that being good at keeping time wasn't just fun, it was useful. Or we might find that musical sensitivity rides entirely on genes that also handle language, attention, and motor control, strengthening the byproduct story. Ancient DNA, pulled from bones in caves and sediments in old lakes, could tell us whether Neanderthals and Denisovans shared our musical predispositions. Did they carry the same pitch-related variants modern humans have? Or did they have their own, now vanished genetic recipes for sound and rhythm? Then there's archaeology. Our earliest known instruments might not be the earliest music. They're just the first things that survived. Somewhere right now, in a cave we haven't discovered yet, there may be an older flute, a drum skin preserved by some freak combination of temperature and minerals, a circle of stones arranged for their resonant properties. We might find new evidence of acoustic design in ancient sites, chambers tuned to amplify certain frequencies, rock art positioned to interact with echoes, wear patterns on bones that only make sense if they were struck repeatedly in specific ways. Each new discovery would push the timeline back, redraw the map, tell us whether music emerged slowly in scattered experiments or burst into existence in a sudden wave of innovation. And then there is the brain. Neuroscience is still in its infancy when it comes to music. We can put people in scanners, play them melodies, and watch which areas light up. We can map networks, track timing, measure the release of dopamine and oxytocin and other chemical messengers when a song hits just right. But we don't yet understand why those networks are wired the way they are. Over the coming decades, more detailed brain imaging, better computational models, and careful comparative studies with other species might reveal whether we have specialized neural circuits tuned just for music, or whether the same flexible circuits get repurposed on the fly. If we find brain structures that only activate for music and nothing else, that would be a powerful hint that evolution carved a niche just for sound's emotional architecture. If instead we find that music always co-opts language circuits, motor planning areas, and general reward networks, like a master of disguise using whatever costume is handy, that would point us in a different direction. There is also the possibility that we'll discover something completely unexpected, a new class of brain cells that track harmonic relationships, a previously unknown rhythm generator deep in the midbrain, a pattern in how musical ability develops in children that overturns our assumptions about what's built in and what's learned. Each of these future finds would change the shape of the question, but even if, one day, we could answer all the scientific pieces, adaptation versus byproduct, single origin versus many, genetic architecture, neural pathways, there would still be something left. The philosophical question: if we explain music, does it lose its magic? Some people worry that it might, that if we know exactly which neurotransmitters are involved when a chord progression makes us cry, or which gene variants make a baby calm faster to lullabies, we'll ruin the spell. That the song will become nothing more than a trick of ions and synapses. But understanding a rainbow doesn't make it less beautiful. Knowing that it's light refracting through droplets of water doesn't erase the shock of colour after a storm. If anything, it adds another layer of wonder. The quiet thrill that the same laws of physics that govern distant galaxies are also painting arcs of colour over your backyard. Music might be like that. Knowing that evolution shaped our pattern-loving brains, that neurons are dancing in complex synchrony when we listen, that ancient lineages carried these abilities through bottlenecks and ice ages and migrations, doesn't make your favourite song feel less like home. It only places that feeling within a much larger story. A story where the same cognitive machinery that kept our ancestors alive on dangerous plains now lets us cry over a slow piano piece played in a dark room. Where the same circuits that once coordinated group hunts now make stadium crowds move like a single organism to a pulsing beat. There's also something else. Explanations describe how something works. They rarely touch why it matters. We can map the physics of a candle flame, but that tells us nothing about what it feels like to sit in its glow on a winter night, reading the last page of a book that changed you. In the same way, brain scans can show us which regions light up during a symphony, but they can't fully capture the way a single melody can make you feel suddenly less alone in a vast, indifferent universe. So no matter how much we learn, there will always be a gap between the mechanisms and the meaning, between vibration and value, between patterned air and the private worlds it awakens. In that gap, the mystery remains, and maybe that's where music actually lives. Not in the bones of ancient flutes, not in the folds of grey matter, not in the numbers of a genetic code, but in that unmeasurable space between a sound and the person who hears it, between one beating heart and another. So as we come toward the end of this journey, let's go back, far back, to our opening image. That first human, somewhere in the darkness, humming. Maybe it was a mother, swaying gently with a restless child, trying to smooth the jagged edge of fear just beyond the circle of firelight. Maybe it was a hunter, waiting in the pre-dawn stillness, fingers tapping a nervous rhythm on a spear, letting the pattern carry his thoughts away from hunger for a moment. Maybe it was a small group wrapped in furs against a wind that smelled of snow, someone idly playing with pitch and breath while others drifted towards sleep. A sound not quite language, not quite animal call, something in between. Whoever they were, they didn't know they were inventing anything. They weren't thinking about evolutionary advantages or neural synchronization or cultural universals. They were just making sound. Because it felt right. Because it soothed something inside. Because it made the darkness feel a little less huge. They couldn't have imagined that hundreds of thousands of years later, their distant descendants would be lying in soft beds, in tall buildings, wrapped in woven fabrics, dyed colours they'd never seen, listening to a human voice, mine, through tiny speakers or invisible waves of data. They couldn't have imagined fibre optic cables spinning under oceans, satellites quietly orbiting the planet, algorithms trusted with choosing the next song. But if somehow they could stand beside you now, if they could listen with you to the faint bed of music under this narration, to the subtle rhythms of your own breathing, something in them would recognize it. Not the style or the instruments or the recording technology, the feeling, that quiet pull when a pattern in sound lines up with a pattern in your body. Heartbeat, breath, the way your thoughts arrive in waves, that softening in the chest, that sense of being gently carried. Right now, as you drift at the edge of sleep, you are part of the same long, unbroken experiment they began, the experiment of turning noise into meaning, of taking the chaotic in different vibrations of the world and bending a tiny corner of them into something that says without words, "You are not alone. I am here. We are here. In this rhythm, in this tone, in this shared silence between notes." We don't know exactly why that works. We don't know exactly when it started, or whether it began once or 1,000 times over. We don't know how many half-forgotten songs were lost in the wind, or how many rhythms echoed through forests and valleys that will never reveal their secrets. We only know that it never stopped. From drums carved in caves to orchestras in great halls, from flutes of vulture bone to synthetic tones generated by circuits, from lullabies whispered in mud-walled shelters to headphones glowing in the dark of a modern bedroom. The song keeps going. And you, listening now, are one more verse in that ancient unfinished composition. So as your eyes grow heavier, as your thoughts stretch and blur at the edges, you can let yourself drift with that idea. That somewhere, deep in your brain, older than your earliest memory, older than your culture, older than your language, there is a pattern-loving, rhythm-seeking, melody-shaped space. A space carved by countless ancestors who survived storms and famines and migrations, who carried within them the fragile seeds of this strange ability to turn sound into feeling. You don't need to solve the mystery. You don't need to decide tonight whether music is an adaptation or a beautiful evolutionary accident, whether it began once in a single trembling voice or 1,000 times in 1,000 scattered camps. You can just listen to the faint music in the background, to the rhythm of your breathing, to the echo, barely audible now, of that first human humming in the dark. Their song hasn't ended. It's here, quietly woven into the air around you, into the blood in your veins, into the gentle cadence of this moment. Let it carry you. Let the unanswered questions settle, just for now, like dust floating down through a shaft of light. There will be time enough when you wake to wonder again why music exists at all. For tonight, it is enough to know that it does, that it has survived every bottleneck, every disaster, every shift of climate and culture, that it has followed us from the edge of extinction to the age of cities and screens, that it is still here, older than language, older than history, older than the stories we tell about ourselves. A soft thread of sound stretching from a nameless ancestor in the dark to you, listening, breathing, drifting slowly into sleep with an ancient song still echoing very quietly in the deepest part of your mind. So now, at the end of this long, quiet journey, you can almost lay the whole thing out in front of you like a landscape. On one side, in the far distance, are those first bone flutes, carved in caves that no one has lived in for tens of thousands of years. Instruments made from the wings of vultures and the legs of mammoths, wind moving through hollow bone, fingers learning the difference between noise and note. Beside them are drums made from animal skin stretched over frames of wood, rattles filled with seeds, voices echoing in stone chambers where firelight flickered on painted walls, people sitting close together, breathing in time, listening to something that didn't have a name yet but already felt necessary. Closer to where you are now, the landscape fills with other scenes, mothers humming to crying infants, hunters chanting before a dangerous journey, people burying their dead with shell beads, ochre, and maybe a final song, groups of early humans gathered under a night sky so bright with stars that it must have felt like the whole universe was quietly singing back. Then the scene shifts again, and suddenly the caves fade into laboratories. The stone circles become MRI machines. Instead of flickering firelight, you get glowing brain scans. Regions of the cortex lighting up in complicated patterns when someone hears a melody they love. Emotional centers, motor areas, memory networks all activating together like an orchestra inside the skull. You see neuroscientists watching those patterns and trying to decode them. Why does this sequence of sounds make people feel joy? Why does that one make them weep? Why does rhythm make the motor system prepare to move even when the body stays still? Why can a single chord progression drag memories from decades ago back into crystal clarity? Somewhere between the caves and the scanners, evolution is quietly at work. You see our ancestors stepping out of that ancient bottleneck, scattered but surviving. Tiny groups, separated by vast distances, still somehow connected. They needed tools, language, fire. They also needed each other. And music seems to have been part of the way they stayed together. Rhythm to march in time, melody to remember stories when there was no writing, lullabies to calm infants whose cries might attract predators, chants to synchronize effort when lifting, dragging, rowing, hunting, ritual songs to make birth, death, and everything in between feel like part of a shared pattern instead of random chaos. Natural selection doesn't care about beauty. It cares about survival and reproduction. Yet again and again, it favoured brains that responded to patterned sound. Brains that felt reward when they synchronized with others. Brains that got a little burst of pleasure when a musical phrase resolved just the way they unconsciously predicted, or surprised them just enough to keep them curious. Somewhere in that long, slow process, language and music braided around each other like two strands of the same rope. The brain reused old auditory machinery for new purposes. Emotional cries became proto-melodies. Gesture and rhythm became proto-grammar. Meaning and music grew up together, sharing neural circuitry, influencing each other, never quite separating. And still, with all of that, the mystery doesn't go away. We can trace the fossils of instruments. We can measure brain activity. We can model the evolutionary pressures. We can list the universals of music found in every culture on Earth. Rhythm, repetition, pitch, structure. We can show how music helps babies learn patterns, how it binds groups together, how it eases pain, how it regulates emotion. But if you ask the deeper question, why does a certain combination of sounds make your chest tighten, or your eyes sting, or your whole body relax? Science starts to fall quiet. It can describe, it can correlate, it can hint, but it can't quite capture the experience itself. That gap right there is where the real mystery lives. The part where a song from a language you don't speak can still make you feel something. The part where a melody from centuries ago can feel more intimate than a conversation you had this morning. The part where music turns time into something you can inhabit. A few minutes where memories, emotions and expectations all line up and move together. Maybe that's the point. Maybe music's power depends on it never being fully explained. The same way a star is still beautiful even when you know its chemical composition, a song is still mysterious even when you can map its frequencies and rhythms. Understanding the mechanics doesn't cancel out the magic, it just adds another layer. Think of all the people across all those thousands of years who have fallen asleep to sound, ocean waves against rock, wind through trees, a parent's voice humming in the dark, a drum heard faintly from a distant ceremony, a radio playing in another room, headphones in a quiet bed, centuries of music condensed into a single human lifetime. You are part of that same unbroken chain. The song started before language. It wound its way through bottlenecks and ice ages, through caves and temples, through choirs and concerts and cracked phone speakers. It's moved through bone and breath and brain and now through circuits and code. And it isn't finished. Every time you tap your fingers along to a rhythm, every time a melody gets stuck in your head, every time you share a song with someone you care about, you're helping to carry it forward. You're one more voice in a choir that has been singing, in one form or another, for hundreds of thousands of years. As you drift towards sleep, you don't need to solve the mystery. You just have to notice that you're inside it. Your breathing has its own rhythm. Your heartbeat has its own tempo. Somewhere, someone else is falling asleep to a different piece of music, under a different sky, carried by the same strange gift. And now, as this little part of the story comes to an end, there's something simple you can do if you'd like this song to keep going here. If you found this journey calming or interesting, you can gently tap like. It helps other wanderers find their way here. If your eyes are still open and you feel awake enough, you can leave a comment and tell us where in the world you're listening from. A city, a country, or just under a quiet sky is enough. It's a way of turning this into a shared space instead of a solitary one. You can also subscribe so that when the next story drifts out into the dark, it can find its way back to you. No rush, whenever you're ready. And if you feel a particular pull to support these long, slow journeys through time and thought, there is an option to join the channel as a member here on YouTube. That kind of support makes it easier to keep creating these deep, gentle dives. It's completely optional. Think of it as adding your own small note to the harmony, only if and when it feels right. For now, though, there's nothing you need to do. Let your thoughts soften. Let the details of ancient bottlenecks and brain circuits fade into the background, like a song gently moving out of hearing. Know that you carry inside your own mind the same strange capacities that survived all those crises and gave rise to all this music. Thank you for spending this time here, for listening, for letting your mind wander through the long history behind a single note. May your rest be peaceful. May your dreams be kind. And may the quiet song that has carried our species this far keep you company for as long as you need it.